In this video, I'm going to be explaining lysosomal membrane peroxidation, and this is crucial when it comes to iron trapped in macrophages. So basically, the lysosomal membranes are rich in BMP and highly unsaturated phospholipids, which makes them extremely sensitive to peroxidation. Now, that being said, unsaturated phospholipids, this might indicate, for example, that unsaturated fats, such as in a coconut oil or some other oils, could actually be bad in this sense, because this could actually make the membrane peroxidized if there was a coconut oil. Okay, so basically, if the lysosome is peroxidized, that means that it can't really handle iron very well. But there are some fixes. The first one is magnesium. Magnesium raises the lysosomal membrane peroxidation threshold, shifting cells away from a chronic leak. The chronic leak happens when the lysosome cannot properly handle iron, especially in the sense of iron trapped in macrophages. But magnesium can help reduce this leakage. Without magnesium, even modest reactive oxygen species can cause micro ruptures and lipid peroxyl chain reactions. So this is why it's important to have your antioxidants of vitamin E, vitamin C. So magnesium indirectly protects by supporting the ATPase function, which means to proper lysosomal acidity and keeping iron ligand bound rather than free and redox active. Magnesium does not chelate iron, but it does keep the lysosomes structured, which means a less iron-driven membrane attack. So low magnesium can actually raise a lipid peroxidation, which is bad in the lysosome, because the lysosome cannot be peroxidized, and if it is, then it can't properly handle iron. And this is where your zinc levels are important, because copper is more membrane toxic than iron in lysosomes. But also magnesium competes with copper for membrane adjacent binding sites. So magnesium reduces copper in induced lipid peroxidation initiation. Magnesium also limits copper amplified phantom-like reactions. But if this is important, why your zinc is needed, is that if copper burden is high, magnesium alone is insufficient to deal with this lysosomal membrane peroxidation scenario, because copper can still generate reactive oxygen species and drive chronic sublethal LMP, or short for lysosomal membrane peroxidation. So this is why you can't just rely on just magnesium by itself to deal with this problem. So without magnesium, the damage accumulates faster than repair. Cathepsins leak chronically, and ferritinolysis becomes abortive. Now, cathepsins is something that is boosted by zinc, and so zinc boosts cathepsins, and with adequate zinc, copper is also reduced, because there is a copper and zinc ratio that has to be maintained. Of course, you have to be careful with high copper, because that will close the chromatin. If chromatin is closed, then the lysosomal genes and transcription factors that are needed will be inactivated if chromatin is closed, which means that the lysosomes cannot handle the iron correctly. Okay, a good chelator of copper to reduce this problem is resveratrol. So basically, resveratrol, it does chelate copper, and copper is actually its preferred redox partner over iron. So copper forms, resveratrol forms copper resveratrol complexes that reduce redox cycling, and also suppresses copper-driven lipid peroxidation. Or in other words, resveratrol can help reduce the peroxidation that copper causes in the lysosomal membrane. So in the lysosomes, copper raises the lysosomal membrane peroxidation threshold in the same way that magnesium does. It allows magnesium membrane stabilizing effects to actually work. So this means that magnesium alone cannot stabilize the lysosomal membrane in a peroxidation scenario. So magnesium needs a resveratrol to work together. Okay, so basically magnesium repairs the structure. Magnesium can only fix it. So if magnesium is by itself, the cause of the repairing of the structure or the damage will still go on. So magnesium will forever be repairing the structure. It's almost as if this is causing a magnesium deficiency, which will also lead to a potassium deficiency, leading to apoptosis problems, because caspases deal with apoptosis. The potassium is actually involved in the caspase activation or deactivation depending on the potassium levels. So if resveratrol is not there to remove the trigger of the lysosomal membrane peroxidation, because magnesium cannot do it by itself, as a result of the resveratrol not being there to help the magnesium will be overwhelmed in trying to constantly repair the structure, because the membrane peroxidation of the lysosome is continuous and endless without the resveratrol there. So this means that there's going to be a magnesium deficiency leading to a potassium deficiency, because potassium cannot work without magnesium, or a potassium deficiency cannot be repaired without magnesium. So this explains why, if resveratrol and magnesium are not working together to stop this iron hoarding of macrophages and iron leaking, because a peroxidized lysosomal membrane will lead to iron leaking. This means that this is caused by iron. Supposedly it's because of a B vitamin B6 deficiency, because magnesium needs a B6. So magnesium makes the copper transporters work, so that the copper, because of the copper transporter, can properly metabolize iron. But if the copper is not there, then the iron is going to be hoarded up by the macrophage. So that's why it's important to keep your B vitamin status good as well. Okay, so the recap here is copper initiates lysosomal lipid peroxidation, which is bad, because the lysosome, the membrane lysosome is not supposed to be peroxidized. Resveratrol removes copper's redox toxicity, because magnesium cannot do it by itself. Magnesium needs the resveratrol. Magnesium stabilizes membranes after copper pressure is relieved. So the copper pressure has to be gone before the magnesium can stabilize the membrane. Okay, now some bonus benefits of resveratrol is that it also boosts PGC1A, and PGC1A boosts mitochondria. So it makes them stronger and more numerous. This is especially important in your immune system, because the immune system is a high energy demanding system of cells, and they need a mitochondria. So resveratrol also boosts brown fat, which is a browning of white adipose tissue, and making white fat more metabolically active. So yeah, that's it for this video. Like, subscribe, leave your comments down below, and I'll about any mechanisms that you know, and I'll see you in the next video.